Hello everyone and welcome back. In this video, I want to talk about the model registry. Imagine that you are working in a tech company and that a data scientist that is working with you has been implemented a machine learning model. So after some time, he came up with a new version of the model. He is happy with the performance of this new model. So he decided to send you an email asking you to deploy this model in production. So you are basically a deployment engineer. Maybe you work as a ML engineer or MLOps engineer. And your task basically is to take this model and to run it in the production environment. But probably after you receive this email, you will start asking some questions. For example, you may be wondering what has changed from the previous version of the model to the new one. Should I update the hyperparameters of the model in production? Is there any preprocessing needed to run this model? Or what is the environment in which this model should run? What are the dependencies and what are the version of those libraries? So all these questions are not included in this email, and you may start replying back and forth with the data scientist to get access to all this information. As you can see, this is not very efficient. And also, imagine that you have some incident in production and you need to roll back the model. So then you will start looking into your email inbox, trying to find what was the previous production version. In some cases, maybe you won't be able to run this model again, so maybe you even want to retrain the model from scratch. But there is no clear link between the model and the code that was used to train the model, or what was the data set, hyperparameters, and so on. If you are lucky enough, the data scientist has stored all this information in a tool for experiment tracking like MLflow. But let me show you how the model registry can make this process much easier. So in the previous videos, we explored how to log the experiment data. For example, we were able to log parameters, metrics, artifacts, and even models that were generated in an ML experiment. For this, we were basically using a tracking server that was running locally. And we sent and stored a bunch of experiment runs and models. After some time, you will start growing the number of models that you have in your MLflow tracking server. You may decide that some of these models are ready for production. In that case, you can register those models into the MLflow model registry. That way, if a deployment engineer has to decide what are the models that are ready for production, they can just take a look at the model registry. Because here is the place in which all the models that are production ready should be stored, and the communication between the person that is in charge of building the model and the person that is in charge of deploying this model can be improved. As you can see, the model registry contains different stages. So actually, the data scientist is not in charge of deploying the model. The data scientist only decides what are the models that are ready for production. Once the model is registered in the model registry, the deployment engineer can take a look at those models, inspect what are the hyperparameters that were used, what is the size of the model, the performance, and so on. And based on that, they may decide to move this model between the different stages. So some models that may be ready for production can be assigned to staging. The current model that is being used in production can be moved to the production stage. And finally, after some time, you may decide to archive some of these models. But you can always retrieve those models from the archive stage and move them back to production if you need to roll back some deployment. Let me just clarify one point. The model registry is actually not deploying any model. The model registry only lists what are the models that are production ready, and the stages are just labels that are assigned to the models. So actually, you need to complement the model registry with some CI/CD code, for example, in order to do the actual deployment of those models. Okay, we are back to MLflow. So this is the UI. And as you can see here, I have trained 4 new models from scikit-learn. I basically enabled the auto login, and then I have trained linear support vector regressor and extra trees regressor, gradient boosting regressor from scikit-learn, and also a random forest regressor. And the auto login already has saved the 4 models, you can see, and this is the error on the test set. So if we sort these models based on the error, we can see that XGBoost is still the best performer, followed by a scikit-learn model, which is in this case let me see, it's a gradient boosting regressor. And next is random forest. Okay, so let's take a look at these 3 models. So the idea now is that we have, let's say, finished the first experimentation run. Now we want to identify which are the models that are ready to be deployed in production. We are a data scientist that has been working on this problem, and as you can see, the first is the XGBoost model. So what I'm gonna look specifically about this run is the duration. We can see here that the model was trained in around 3 minutes. So this is important information because later this will allow us to understand which model actually makes more sense to be promoted to the production environment, right? For example, I can see that this model has achieved the lowest error. Another important detail here is that the size of the model is 9 megabytes. Okay, just remember this. So around 3 minutes, the error is 6.3 and the size is 9 megabytes. If we go to the second best model, in this case, it's the gradient boosting regressor, and the error metric is 6.7. So it's a slightly higher error compared to the XGBoost model, but here you can see that it only took 3.6 seconds to train, okay, versus 3 minutes. Of course, this is just a toy example, but this is the kind of information that you need to consider when you are evaluating, between different models to be deployed in production. And let's check the size. So you can see that it's also quite a light model. The size is only 115 kilobytes. And if you remember here, the XGBoost model is the size is 9 megabytes. So it's quite smaller. And finally, in the case of the third model, this is the random forest regressor, and we already can see that it took around 7 minutes to train, so it's much slower compared to the other 2 models. This, of course, in production won't make the difference, but typically, the models that train during a longer period of time tend to be, more complex, so the size of the model will be bigger. And the metric, yes, is slightly worse compared to the gradient boosting regressor. And finally, the size of the model, yes, this is much bigger, it's 460 megabytes. So based on all this information, what I will decide actually is that I'm gonna promote the XGBoost model to the model registry. And I will also promote this gradient boosting regressor to staging. So to do that, I just need to click here on the model, and there is a button here. If you remember, this is the section that contains also the snippets to make predictions using your model. I'm gonna click on this button over here to register the model. First of all, we need to select the model. So we haven't registered any model so far, so we will need to create a new one. I'm gonna call this New York City Taxi Regressor. So I'm going to register. That's it. And now you can see that the button has disappeared, but instead we have here a link to the register model. But let's first register the second model. And in this case, we don't need to create a new model. We're gonna register using the same name. And there you go. So now I'm gonna click here and okay, so here is the model registry tab. So before, remember, we were on the experiments tab, in which you have the list of experiments and run, but now we moved into this model registry tab. So here you have the list of all the registered models, and there is only one, this New York City taxi regressor that I have just registered, and it says that there are 2 different versions of this model. If we click on the link, we can enter to the register model details, right? So here you can include some description. For example, this is the New York City taxi predictor for trip duration. Okay, some basic explanation of the model. You can also add some tags here if you want to easily search for models and retrieve them. And here is the list of all the available versions for this model. So you can see that MLflow automatically assigned different versions to the 2 models that we registered. The first one is the XGBoost model. So actually, there is no information here about which model is, but you can click on the run here and it takes you to this run, and you can see here that is the XGBoost model. You can retrieve the metrics, parameters, and all the information. So that means that you have model lineage, right? So you can link this model version with which experiment run was used to train this model. You can also add tags here and a description for this specific version. So I'm gonna include a tag with the model, and this is XGBoost. Okay, so here is the XGBoost, and next let's also take a look at the second model that was registered. So here we are. If I click here on the run, I can see the details of this model. In this case, this is the gradient boosting regressor. This is let's go back here. I'm gonna add a tag here also, model, and in this case GDBT, actually gradient boosting regressor. I'm gonna call it like this, gradient boosting regressor. Okay, so this is it. Now what I wanted to show you, we have to register these two models using the UI. We actually can assign these models now into different stages. As I mentioned before, what I'm gonna do is to move this or transition these two models to the staging. So here basically it's asking me if I want to archive the versions that were currently on the staging. I don't have any model on the staging, so I'm gonna just click on OK. And I'm going to do the same with model version 2. So what I'm doing here is like, me as the data scientist working on this model, I decided to register these two models into the MLflow model registry, and I also decided to move both of these models to the staging. Sorry, yes, I need to transition back this to staging and yes, disable this tick because otherwise we'll archive the other model. Okay, so let's go back. And here we are. So we have the two versions and both of them are currently on staging. So the next step will be that deployment engineer will take a look at the registry, will decide, based on maybe the metrics of the model and some details, will decide which model should be promoted to a staging. For that, we need to go now to the code. And now I'm going to show you how to use the ML client class. First thing we need to do is to import the class and then instantiate the object. It's this one. And we need to provide the tracking URI. So in this case, I'm going to create a variable so we can reuse it in the future. I'm going to use the same SQL database that we were using so far, so we get access to the models that we stored in the artifact, and the artifacts, models, and metadata. So now we can access this object. It contains a bunch of methods. For example, you can interact with experiments, you can interact with runs. Actually, you can get the run, create the run, search for runs, and also for models, right? Like, for example, get a model that is already registered, or search for models that are registered, and so on. So first of all, let's check what are the experiments. Let's experiments. So here you can see only two experiments, which makes sense. There is the default one and the experiment for New York City taxi experiment. We can also create a new experiment. For example, we need to provide here a name. This is the same thing that we did before in the MLflow UI. In this case, we are using basically the Python API. So this will be my cool experiment. Okay, so it takes some time and then it is created and it returns the ID of the experiment. If we go back to MLflow and check the existing experiment, let's refresh this, and here you can see there is a new experiment. Regarding runs, we can, in this case, let's imagine that we are trying to understand for a given experiment what are the best models or the best runs. So for that, we can use the search runs method, and this will return a list of runs. So I'm gonna save it in a variable. The first parameter, I think that is the experiment ID, and I'm gonna search for the experiment with ID 1, which is the New York City taxi experiment. We need to provide a filter query, filter string, which in this case I will left empty, and around view type. So in this case, we need to indicate if we want to keep only the active runs or want to include the deleted ones. So in this case, this is an enum type. So I'm going to import this enum. So from MLflow entities, import view type, and let's only keep the active runs, and max results is the next parameter. I'm gonna pass 5. I want to see only 5 runs that apply to this search. And finally, the order criteria. This is a list because you can include multiple criterias and you need to pass a string. So I'm gonna sort them by root mean square error. So this is root mean square error ascending, okay, because I want the top 5 considering this. So now we can see this object is a list of runs. We can actually print this in a nicer way for run in runs. Print, let's print just the run ID. This would be run dot, I think there is info, run ID, and yes, what was the metric, right? That root mean square error. And this should be run dot data dot metrics. This is a map with a square, and I'm going to show only 4 decimal points. And here we can see this is the ID of the run with the lowest root mean square error. And if we go back to MLflow, we can see here that basically this is the root mean square error of the XGBoost model. And if we click here, we can compare this number, this ID, with this one. So yes, they are exactly the same one because I'm just interacting with the MLflow server through Python, but I'm basically accessing the same data. And you can do the same here, right? You can put matrix root mean square error lower than 0.7 and search here. So there is no metric, so 0.8. Okay. I mean, you can, this is already sorted by root mean square error. Okay, it's lower than, so metrics that root mean square error lower than 6.8 here, and then you get the results. So you can do the same here. You can say lower than 6.8 and run it. Okay, was not possible. Let's check what happened. So order by, okay, because this is order, sorry. So this is the sorting. So this doesn't make sense. In this case, I will go back to ascending here, and then we need to put the filters here, lower than 6.8. In this case, it runs, and we get the 2 models which have a lower root mean square error. Okay, so yes, so using this code, you basically can inspect the runs of a given experiment. In this case, the experiment with the ID1, and get access to certain runs. Maybe you can use, the tags also here to filter a subset of experiment runs. And the next step would be to promote some of these models to the model registry. For that, you don't need to use actually the client in this case. So let's import MLflow. You need to set also here the tracking server, because otherwise you would try to look for the models in the local folder. And the URI is the same one, MLflow tracking URI. Okay, so and now we can use this method register model. You need to pass the model URI and the name of the model. Let's maybe, because these top two models were already registered, but I'm gonna change this filter. So now we have more models, and I'm gonna register this one. So this would be the model URI would be, I'm gonna put it in a variable to make it more clear. So model URI, and you need to pass remember runs. This is one way to access the, and here the run ID and the artifact path, which is a model. And the run ID is this one. And the name is the name of the model that we already created, this model that is registered. And let's go back here. So if we go to models, it's this New York City taxi regressor. And this should be it. Yes. So In this case, it fails because the model already existed. If a register model with the given name does not exist, it will be created automatically, but it already existed. In this case, we cannot upload this model yet. Okay, this is also wrong. Okay, it worked. So the problem was I forgot to add the F here. Now the model URI makes sense. Let's print it here. So you can see it's the run keyword, then the run ID and the name of the folder. Okay, so we registered a new version of the model, and if we come here, we can see there is a version 4. We click on the model, so there is version 1, 2, 4. I made some tests before, so the version number 3 doesn't exist anymore because I deleted it. And the next thing that we can do now is this is basically how you can register a new version of the model and create a new version. Now I wanted to show you how to transition a model from one stage to another. So first we will check with this client the list of registered models. So here we can see is only one model and there are a few versions. And so get latest versions for this experiment. The name of the model, so model name. I'm gonna put it here in a variable. Name is the new city taxi regressor, and this will return all the versions that we just uploaded and registered into registry. I'm gonna list it. So this is latest versions. Sure, and latest versions. Let's print here so this contains a lot of information, but maybe the stage, current stage, version, and stage, and what else? Yeah, that should be it. Maybe this tax and the version. This is the version. So we can see that there are 3 models. One of them is in staging, the second one is in production, and the fourth one, yes, we didn't assign any stage to this model. So let's say that we want to transition this model to a staging, for example. In that case, we can also use the client, so transition model version stage. So the name will be model name that we defined above. And I want to change the version 4. I want to transition it to staging and archive existing versions false. Good. So now if we refresh MLflow, we can see that the version 4 is in staging and there is also the version number 1 in staging. So 2 of them are in the same stage. So this is the kind of things you can do with the MLflow client. As you can see, very easy to register models, to get the latest version of a given model, or to transition a model. The registry also allows you to annotate the model. So for example, model description. So I think there is okay, update model version. You need to pass the name of the model name, the version 4, and perhaps I don't know, automatically you can change the description with something like the model version, and then you pass the version was transitioned to, and here the stage, right? We can put this in variables. So model version or stage or new stage will be staging, and then we just need to replace these values. This will be model version 2. I'm going to also add the date. So for this, I'm just going to call datetime. Execute this. The date is datetime today. Model version is not defined. Okay, let's check now version 4. And yes, here we can see that there is a description associated with this version number 4. It says that the version number 4 was transitioned to staging on this date. Okay, so the last thing that I wanted to show you, what's this? Yes, so this is small version, and this is new stage. And the last thing that I wanted to show you is, so in this case, we already have some models, right? That some of them are in the staging stage, some of them are already in production. And let's say that now we want to decide if we want to promote some of these models that are in staging into the production environment and maybe archive the model version 2, which is currently in production. So for that, we can come up with some code. I already prepared some code. I'm gonna use it. This is a code that I prepared. I need to import pandas here. Okay, so this is the code that I prepared to read the data frame, the same way that we are doing so far, to preprocess the dataset using the vectorizer preprocessor. And here it's important to notice that we are not fitting the preprocessor again, we're just transforming the data using the fitted preprocessor. And then this method basically given a stage and a test set and the name of the model. So I'm gonna change the order to make it more clear. This is the name of the model, the stage. Okay, so for example, we can ask, I want the version that is in production for the model New York City taxi regress. And then we need to pass test set, and this will load the model as a Python function. Okay, we can load it like this, passing models, the name of the model and the stage. And then it's going to make a prediction on the test set. And finally, it's going to return a dictionary with the root mean square error, the same way that we were calculating it before. It's a super simple version, and for this what I did also is to download the data for March of the green taxi trip data set. We were using January for training, February for validation, and now for test. So to decide which model we want to promote to production, I decided to download the month of March. And let's execute this. So we need to do a few things here. We will need to first read the data frame. This we have this method here. Need to pass the name of the file. Okay, and this is in the data folder. Also, we will need to load the preprocessor. Remember that this is currently on MLflow, so I'm going to just use the client here again using this method download artifacts, and I'm going to pass a run ID because we were using the whole time the same preprocessor. So I'm going to just use the run ID that I defined above here for the scikit-learn model because we are using the whole time the same preprocessor, but you should make sure that you use the right preprocessor for your model. To do that, you need to recover the run ID for each of these models. So I downloaded the preprocessor, and now I'm gonna just load it using pickle. Open, I downloaded the preprocessor locally, so it's here. There is now a folder preprocessor which contains the dict vectorizer. I'm going to just load it with pickle, and then we can call the preprocess method, which take data frame, which is the test data frame, and the dict vectorizer. Okay, it took 0.1 seconds. And the next steps will be to test the models using the methods that I defined before. But first, I need to define the target, which is the column called duration. Why test, right? The target is df target values. I'm applying the same preprocessing from the previous notebook that was created by Alexei. So I'm just following the same logical steps. And now I'm gonna make a call, right, to test the model. And I'm gonna measure the time. For that, provided this method test model. And let's check first for production. First, the name. We need to pass the name of the model, which is model name. The stage will be production. And then we pass X test and Y test. Okay, so if we run this, we can see that this model that is in production achieved 6.65 root mean square error. And now let's check the model that is in stage. Staging, we do the same, and it's taking much more time, right? So actually it doesn't improve the results. So it's slower. You can see here that it's slower and the performance is actually higher. So I wouldn't move this model to production unless we know that there is some maybe data drift going on and that we are required to update the model from time to time to cope with these differences in the data. So if this model was running for a long period of time, maybe we can consider in any case deploying this model, but you can see that it's much slower and the performance is worse. So in this case, I wouldn't transition it, but if we want to do it, we can do just client, transition model version stage. And here we pass the name of the model name, and the version of staging was, let's remember, so this version 4. And then we need to say the stage will be the new stage production and archive the existing versions. True. I'm gonna just do it for the sake of completeness, but again, this is something that actually doesn't make more sense, but still considering different scenario in which the new model that is in staging is performing better or similar, and they also make a prediction in a similar time, then maybe this is what we will do, right? Just transition the model to production. Let's update this. And yes, we can see now the model version 4 is in production. Version 2, it was the previous production, was archived, and the model version 1 is in staging still. Something that you may notice is that this model says that move to production, right? And the date. I mean, this is still true, but we also should update this model version 4 saying that the model now was transitioned to production. And this is just, maybe some annotations that you can include in the model description just to make all these transitions more transparent. And if there is any problem with some model, you can always understand, where this model comes from, because you can always come back to the run ID here and retrieve the parameters. So here you can see the model that is in production right now is the random forest regressor. We already knew that this is not the best model, but still we deployed. And you can see, how to reproduce this model, the environment, variables, and everything. Okay, so let's do a quick recap. So today we saw that we can easily register models that were saved or logged in the MLflow tracking server into the model registry. I showed you how to move these models, transition them between the different stages. I also showed you how to retrieve those models and apply them to new test data to compare their performance and add annotations to the different versions of the model, and to also create new models in the registry or delete them. We were interacting with this MLflow client class, which is super useful to interact with the tracking server and the model registry. Remember always to pass the correct tracking URI, and the same applies when you are using just MLflow, the API. You need to, when you start, for example, logging experiments, you need to pass proper tracking URI. Otherwise, MLflow will assume that you are looking for models and metadata that is stored in a local folder. But in this case, for example, I'm passing a SQLite database, but I could also pass maybe the URL of a remote server. And regarding the model registry and how to do model management with MLflow, in a nutshell, this is a centralized model store. And I show you that there are a set of APIs. We explored the Python API, but there are other ways to also access the registry, like a Java API. You can also access it from the command line interface from MLflow. And of course, you have the UI, and we also explore how to register models and transition them from the UI. And this allows you to collaboratively manage the full life cycle of an ML model. So you were able to see how we take a model that was related to some run within a given experiment, and this model we promoted them maybe to the registry, then we assigned some of them to the staging stage, and then we transitioned those models to maybe production, and finally we decide to archive some of them. So this is the full life cycle, right, of the model. So it provides model lineage because, as I showed you, you have control of all the information about how the model was built. When you look at the details of a model in the registry, you have always the link to the model run. You can find there all the details. You have automatic model versioning, so you were also able to see that every time we register a model or a new version, the versioning was automatically incremented by one. I also show you about the stage transitions and annotation. So this is it for today. In the next video, we are going to talk about how we use MLflow in practice and some suggestions about how to deploy it. And if you're working maybe in a tech company and you need to interact with more people, what would be a good setup to deploy this server in a remote fashion. So yes, see you later.